I request you to please like and share my videos and subscribe my channel if you have not already subscribed. Thank you. In this video, we discuss two questions, question number 67 and 74, that have appeared in the TS Set 2023 October examination from the chapter Complex Analysis. And these two questions are suitable for the aspirants of junior lecturers, degree lecturers, AP Set, CSIR Net. We first take up the first question, that is the question number 67, bearing the question ID this one. The given question is integral 0 to infinity 1 minus cos 2x by x square dx is equal to, we are given four options. And many students do remember the value of this integral 0 to infinity 1 minus cos 2x by x square dx. If you know it directly, tick the correct option from this one. Now, my idea here is to discuss this question in detail for all those people who do not know the answer to this, can learn how to do it. And this is the evaluation of the real integrals using the complex analysis. Right. So, let C be the closed contour as shown in the figure. So, we take f of z to be 1 minus e to the power of iz by z square as our function. Right. So, we take, let fz is equal to 1 minus e to the power of 2iz by z square. This is what we have considered. And you know that this is analytic everywhere except at z is equal to 0. And that is why in this closed contour C, the closed contour C consisting of the semicircle gamma is a semicircle with center at 0 and a radius capital R, and the part of the real axis minus R2 minus rho, and then the semicircle gamma in the positive direction, and then the part of the real axis from rho to capital R. That is our closed contour C. So in this closed contour C, this singularity is not there. It is outside now. Therefore, it is analytic. Note that f of z is analytic inside and on C. Therefore, using Cauchy-Goursat theorem or Cauchy's fundamental theorem, the integral taken round C, f of z dz is equal to 0. Agreed. And this integral can be broken into four parts. That is the integral taken along the semicircle capital gamma, and the part of the integral minus r to minus rho of along the x-axis fx dx plus integral taken along gamma in the clockwise direction of that semicircle, smaller semicircle f of z dz plus integral rho to r fx dx along the x-axis. Agreed. Right. Now, we consider integral minus r to minus rho f of x dx. And f of x is what? 1 minus 2ix by x square dx. Now replace x by minus x and do it. I am not showing it. Replace x by minus x in this. This integral becomes integral rho to r 1 minus e to the power of minus 2ix by x square dx. Agreed. And this is same as now minus r to minus rho fx dx plus rho to r fx dx minus r to minus rho, we have shown integral rho to r 1 minus 2ix by x square dx plus integral rho to r fx dx is 1 minus 2ix by x square dx. Add. Both are integrals from rho to r only. So integral rho to r 1 plus 1 2 minus in brackets e to the power of 2ix plus e to the power of minus 2ix by x square dx. E to the power of 2ix plus e to the power of 2 minus 2ix is 2 cos 2x. That is 2 is taken common. Integral rho to capital R of 1 minus cos 2x by x square dx. Right. Now you can guess now. As rho tends to 0 and capital R tends to infinity, you will get integral 0 to infinity 1 minus cos 2x by x square dx from here. So you know what to do now. What to do. So with this, what happens to 1? The 1 happened, 1 for 1. Integral taken along the semicircle capital gamma f of z dz plus integral taken along small gamma f of z dz plus 2 times integral rho to r 1 minus cos 2x by x square with respect to x is equal to 0. Let's call this as the equation 2. Right. So we'll start with that, the equation 2. And we take what happens on capital gamma of f of z dz. So for that, mod fz we have taken. Mod of fz is 1 minus 2iz by z square. Modulus of 1 minus 2iz is less than or equal to mod 1 plus mod of e to the power of 2iz. Mod of e to the power of 2iz is 1. 1 plus 1 2 by mod z square and 2 by mod z square on the semicircle gamma mod z is equal to r. So therefore it will be 2 by mod z square will become 2 by r square. As r tends to infinity, the integral will become 0. This is the result what we have. Limit r tends to infinity, integral taken along gamma of f of z dz is 0. Because 2 by r square, as r tends to 0, it is 0. So as capital R tends to infinity, integral taken along gamma is 0. So what happens on the small gamma, integral taken along small gamma f of z? So now integral taken along gamma f of z dz is equal to integral taken along gamma 1 minus e to the power of 2iz by z square. To evaluate this one, and this is on gamma. On gamma, the semicircle mod z is equal to rho e to the power of I theta. For that reason, put z is equal to rho e to the power of I theta in this. Then dz is equal to rho I e to the power of I theta d theta. And that will be, and the theta varies from pi to 0. Why? It is in the clockwise direction from pi to 0, not 0. 0 to pi means anti-clockwise direction. So it's a clockwise direction. Therefore, the integral will be pi to 0 of 1 minus e power 2i into z is rho e to the power of I theta by z square, rho e to the power of I theta whole square into dz is rho I e to the power of I theta d theta. Now rho e to the power of I theta, rho e to the power of I theta cancels, and 1 rho e to the power of I theta will remain in the denominator, and I will come out. So that will be I will come out, and integral pi to 0 we have written as integral 0 to pi. For that we have put a minus here. So minus I into 1 minus e to the power of 2I rho e to the power of I theta by rho e to the power of I theta d theta. Agreed. Now what happens? Limit rho tends to 0. That's what we want. Limit rho tends to 0 of integral taken along gamma f of z dz is equal to minus I into limit rho tends to 0 integral of 0 to pi 1 minus 2I rho in the powers only rho e to the power of I theta by rho e to the power of I theta d theta. And as rho tends to 0, if you see here 1 minus 1 e power 0, 1 minus 1 0 by 0, 0 by 0 form you will get. And yes, limit rho tends to 0 will go inside also. Yes, 0 by 0 form, L'Hopital's rule will apply. So that will be minus I into limit rho tends to 0 integral 0 to pi. The integral of this is minus, no, I'm sorry, the derivative, differential of this with respect to rho. So minus e to the power of 2I rho e to the power of I theta into 2I rho e to the power of I theta with respect to rho is 2I e to the power of I theta by the derivative of rho e to the power of I theta with respect to rho is e to the power of I theta. Rho has gone. Limit rho tends to 0. This minus 2I will come out. This will be 1. This will be 1. This will be 1. So integral 0 to pi d theta minus I into minus 2I. Minus I into minus 2I. Integral 0 to pi d theta. And that will be integral d theta is theta from 0 to pi is pi. This is minus 2 pi. So all the entries we have found out. Integral taken along capital gamma as capital R tends to 0, tends to infinity is 0. Integral taken along small gamma f of z as limit rho tends to 0 is comes out to be minus 2 pi. Go get into the second equation and substitute that. So this is 0. As r tends to infinity and rho tends to 0, this 2 becomes, this is 0. The value of this is minus 2 pi plus 2 times integral rho tends to 0 to infinity 1 minus cos 2x by x square dx. And 2 cancels. This is integral 0 to infinity 1 minus cos 2x by x square dx, that is equal to pi. That is your answer. The answer, many students do remember the value of this one as pi and they simply put the answer there. Those of you who have not familiar with the result, learn from here and remember. So the answer to this question is option 2. So that is the detailed discussion of the solution of the problem of evaluating this integral using contour integration. That's what we have done it. Right. Now we move on to the next question. This is question number 74 with this question ID. Right. The circle of convergence of f of z is equal to 1 by z square plus 1 into z plus 1 plus I about the point z naught is equal to 1 by 2, and you are given 4 options. So these are the circle of convergence of this one. So that means you take your function f of z about this point z naught is equal to 1 by 2, write down, get its Taylor's expansion, and once a Taylor's expansion will have a circle of convergence, and we have to find the circle of convergence of the Taylor series. But you see, you need not get into the Taylor series expansion of this function about this z naught is equal to 1 by 2. You need not get into that. You can do it without doing it also. I will show you how it is. The circle of convergence of f of z, that is 1 by z square plus 1 into z plus 1 plus I about the point z naught is equal to 1 by 2 is given by modulus of z minus z naught is equal to r. Yes, that is modulus of z minus 1 by 2 is r, where r is the radius of convergence of the Taylor series of this function f z about the point z naught. Right. Now, how do you find r? Now, recall r is computed as the distance between the center of the circle z naught and the nearest singularity of the function f z. So, get into the function f of z and find out what are the singularities are there and measure its distance from z naught from those 4 singularities and take the minimum of them, and that will be the capital R. So, now f of z is analytic everywhere except at z square plus 1 is equal to 0, z plus 1 plus I is equal to 0. That is here z is equal to plus r minus I, z is equal to minus 1 minus I. Who are these? These are singularities, alright, but they are poles. Right. Now measure the distance z naught, that is 1 by 2 to I, 1 by 2 to minus I, 1 by 2 to minus 1 minus I. Right. Now R, the minimum of the distance of z naught to z belongs to the set of the poles plus r minus I, comma minus 1 minus I. If you measure, this is the smallest distance. D of the distance between 1 by 2 to I or 1 by 2 to minus I, they will, both of them have under the square root of 1 by 2 square plus 1 square, that is root 5 by 2. And you can compute what is the distance between 1 by 2 to minus 1 minus I also. That will be bigger than this one. So this is the minimum value, right? So the circle of convergence of f of z about z naught is equal to 1 by 2 is modulus of z minus 1 by 2 to r. R is equal to root 5 by 2. Take the LCM. Take the LCM. That is mod 2z minus 1 is equal to root 5. And where is it? That is the option 3. The answer to this question is option 3. That is the detailed discussion of the solution of this problem. So in this video, I have discussed 2 questions. One is the evaluation of integral using contour integration. The other is computation of the circle of convergence of a given function about a given point. Right. I am sure that you have understood the solutions of these 2 problems. If you like my videos, please like and share the videos with your friends and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.